Hey fellas, what's up? Welcome to the second episode of my mini-series about the quadratic function and how to find different properties related to it. Now we're gonna be working on this specific feature of the quadratic function, that is the zeros. What are the zeros? The zeros are values of the input. This is the input x that return a value of 0 in the function. So the mission basically is finding these values of x that are going to make that the function is equal to 0, or in other words, that make that this quadratic equation is solved. So what are the strategies that we are going to use in order to achieve this task or to complete this task? Well, we are going to have 4 alternatives. The first one of these alternatives is graphing. That basically graphing consists in creating a table where we're going to use different values of x as input, and we're going to start getting the values of y. After that, we plot all that information in a Cartesian plane, and we start inspecting where are those values of x, where the function crosses the x-axis. Problems related to this: if you are not using a graphic calculator, if you are not using some type of tool that helps you to sketch this function in the most precise way possible, what is going to happen is that you are not going to get a consistent or accurate calculation of these values where the function is crossing the x-axis. That's something that you don't want in math. In math, you always want to be as precise as possible. So that's why some better alternatives, more analytical alternatives, should be found. And what are these other alternatives? A second alternative that you may consider is factoring the expression. Why factoring the expression? Because when you factor an expression that has this shape, what you're going to arrive to is to the roots of this expression, and the roots of this expression are going to be exactly the same as the values of the zeros of the function. So this is a good alternative that we may consider. Completing the square is a third alternative that we're going to explore in this channel, and that is going to be very useful. So useful that it's going to take us to a fourth method that we have to solve this problem, that is the quadratic function. The quadratic function is one of the most straightforward methods, one of those that is going to take you without any problem to a solution of any quadratic function that you may think about. So in this video, we are going to explore 3 of these methods, or in this channel we are going to explore 3 of these methods that are factoring by computing the square and also by the quadratic function. So we are going to start in this specific video with factoring, and then we're going to move on to some other strategies. Okay, now let's talk about finding the zeros by factoring. What is finding the zeros by factoring? When we factor, we are trying to find the values that are going to return the same expression, the same original expression. I mean, factors are numbers that when multiplied return another expression. I will explain you with an example better. This is an expression that has the shape ax squared plus bx plus c is equal to 0. So this means that this expression is going to be object of research in order to find the zeros, or the points where the function is crossing the x-axis. So this is the question that we want to answer. Where are the points where the function is going to pass by the x-axis? We previously stated a rule. This rule says the roots of an equation ax squared plus bx plus c equals 0, where a is different to 0, are the zeros of the respective function. So considering that, let's jump to a solution or to a search of those roots of this function. I need 2 numbers or 2 expressions that when multiplied return this original expression. So for doing this, I'm going to create 2 parentheses that are going to enclose my possible solution. All this is equal to 0, of course. The first element in each one of these parentheses is going to be the square root of the first element that I have here in my expression. So the square root of x squared is, that's right, x squared. X, only x. just to clarify, the square root of x squared is equal to x and x, and this is the first element that I'm going to write inside these two parentheses that I previously drew. Now I need to find two numbers that when multiplied return 12, positive 12, and when added or subtracted return negative 8. So probably you could do that by simple inspection, but if in case you can't, it's a good strategy to create a table with the factor pairs. So 12 is a number that can be formed by the multiplication of 1 and 12, 1 times 12, 2 times 6, also 3 times 4, and that's it. Those are the factor pairs that this number has. So now we can start inspecting for, or we can start looking for two numbers that when added or subtracted return negative 8, which is the number that I have here. So these two numbers would be negative 2 and negative 6. Negative 2 times negative 6 is going to equal to positive 12, which is this number that I have here. And negative 2 plus negative 6 is equal to negative 8. So this means that these are the two numbers that I'm looking for, and I'm going to write these numbers here, where in the position for the second element in this binomial here is I am going to write minus 2, and minus 6. Once I did this, what I can apply is the zero rule. What is the zero rule? The zero rule says the following: if this 0 is the product of two numbers that are being multiplied, then necessarily one of these two numbers needs to be equal to 0, because 0 times whatever is going to equal to 0. So what we need to do is to make sure that one of these parentheses is equal to 0, or the other parenthesis is equal to 0, and that's what we're going to do in the next step. We organize the first factor that we have here as x minus 2 is equal to 0, and then we can organize the second factor as x minus 6 is equal to 0. As we have that, the only thing that we have to do is to clear the x's in both expressions. In this first case, we have that the first x that we are finding is equal to positive 2, because the negative 2 passes to add to the other side. And in the second one, we have that x is equal to positive 6. So now we are going to inspect if this is making sense with a quick review in our GeoGebra. And now, with a quick jump here to my computer, I have here the function that I am exploring, that is x squared minus 8x plus 12, that would be this one, and this is the sketch of the function. Now, if we inspect the points where the function is crossing the x-axis, effectively I have that this is happening in x equals 2 and in x equals 6, which means that our calculation is properly completed. So this is a way to find the values of the x-intercept, or the points where the function is crossing the x-axis. Now, our mission is going to be to explore the other two methods that we have to disclose, that are by computing the square and by the quadratic formula. So take a look to my next video in order to understand how to do the same procedure that we did here, but with the method of computing the square. Goodbye. Thanks for watching. If you arrived here, remember to follow me. This is very important to me. See ya.